Hi everyone, welcome to the next subtopic called heat conduction and thermal expansion. Okay, we start with the first subtopic called heat conduction. What is actually heat conduction? Heat conduction is also known as thermal conduction. Okay, it is defined as a process whereby heat is transferred through a solid from a region of high temperature. Okay, heat travel from high temperature to a region of lower temperature. This is very important. It starts from what? Heat always flow from where? From high temperature to lower temperature. The net heat flow always from high to low temperature. There's never net heat flow from lower temperature to higher temperature. Okay. Now, for example, this is a metal rod. Okay, you're heating the metal rod at one end. So the end which is being heated, it has high temperature, and the place you hold has low temperature. But after some time, you'll feel that the metal rods will become hotter and hotter. Yeah, hotter and hotter. So why is that happen? It is because of thermal conduction or heat conduction. Why the metal rod in the end, the whole metal rod become hot? It is because the heat flow from high temperature end to low temperature end. Okay? Heat only flow if there is difference in the temperature between 2 points. There must have one high temperature end and another with low temperature end. Then only got heat flow between the two different temperature. If both end has same temperature, if you don't hit the metal rod, if let's say the metal rod you don't hit it, yeah, you just hold, at here. Both have same temperature. Temperature 1 and temperature 2, they have the same temperature. Is there any heat flow? Is there any heat flow? No. The heat don't flow. There's no net heat flow because the temperature at both ends is the same. So there's no heat flow. Okay, sorry. There's no heat flow between two ends with same temperature. So heat only flow when there is different in temperature. Like this one, you have hot end and cold end. Then heat will flow from hot to cold end. And you see, heat always flow from high temperature to low temperature. It never flow from low to high temperature. Okay? So, the hot end, the high temperature, is the initial temperature. Initial temperature. The low temperature end, which is the cold end, the low temperature is the final temperature. Heat always flow from hot to cold. This is called heat conduction. So heat only flow if there is difference in temperature. If same temperature, heat don't flow. Okay, so let us look at the equations we have for heat conduction. This is the equation for heat conduction. Yeah, we have dq over dt equal to negative Ka dt over dx. Okay, let us focus at this equation. Okay, dq over dt equal to negative Ka dt over dx. So what is actually dq over dt? So dq over dt is called the rate of heat flow or energy over time. Okay, energy over time. So energy over time is actually thermal power. You see, this is why this is power? Because this is power. Power is actually energy over time, and this time the energy is the heat energy. Heat energy divided by the time. So this thing is the thermal power. Yeah, we call it thermal power. Yeah. So the rate of heat flow, we have the rate. Yeah, heat divided by rate. Rate is the time. Heat divided by time is the power. So rate of heat flow is the same as thermal power. So sometimes question will ask thermal power instead of rate of heat flow, but they refer to the same thing. Okay, power is the rate of heat flow, dQ over dt. So rate of heat flow, the unit is watt. Why is it watt? Because it is power. Power is watt or joule per second. Yeah, energy over time, joule per second. Okay, so dQ over dt equal to negative K. K is called the thermal conductivity. Thermal conductivity, it has unit, yeah, watt per meter per Kelvin or watt per meter per degree Celsius. So you can get this unit by rearrange the formula. I just show you. Yeah, if you want to get the unit for K, very simple. You just divide. Just now dQ over dt equal to negative Ka dt over dx. So if you want to get the unit for K, you just dQ over dt divide by area dt over dx. So what's the unit for dQ over dt? dQ over dt is watts. And what is the unit for area? Area is meter square. And what's the unit for dt over dx? Temperature. This is a Kelvin per meter. Yeah, or per dx. Dx is a distance per meter. So you cancel out. Yeah, you cancel out the meter square with per meter. Finally, you will get what unit? You will get watt per meter per Kelvin. That's how you get the unit for K. Okay, the thermal conductivity. So that's the K. Now, what is actually thermal conductivity? Thermal conductivity, it depends on the type of material. Because when we have high thermal conductivity, high value of K, means that material easy to conduct heat or faster to conduct heat. Faster become hot. For example, different material has different ability to conduct heat. Some material conduct heat faster, some material conduct heat slower. For example, like the steel. The steel has very high, we can say the steel has very high thermal conductivity because steel, if the pan, if the pan is, the pan or the wok, if it is made of steel, when you heat it, in a short time, it becomes very hot because it has, when the material is made of steel, it has high thermal conductivity. Very fast, it becomes hot. Because this material very easy to conduct heat. Okay, but if let's say the pan made of glass, so if you try to heat the glass, so until when the pan will become hot? It never become hot because it has very low. It has very low thermal conductivity. So this glass has very low thermal conductivity. Yeah, very slow to conduct heat. Very hard to conduct heat. Yeah, it takes very long time to conduct heat. So different material has different. Yeah. So thermal conductivity, it depends on type of material. Different material has different value of thermal conductivity. So thermal conductivity refer to type of material. Okay, different material, different thermal conductivity. Remember. It's just like the Young modulus. Still remember the Young modulus? The Young modulus, the Young modulus. Still remember? This one is called the rigidity of material. It also depends on the type of material. For example, like Young modulus for steel, is higher than Young modulus for copper. Because we know that this steel material is very stiff, very hard. Yeah, harder than the copper. Copper is a soft material. So steel has very high Young modulus. Copper has very low Young modulus. So Young modulus also depend on the type of material. Just like the thermal conductivity also depend on type of material. Different type of material, different thermal conductivity. Okay, that's it. Now, how about the, then we have area. This is the cross-sectional area, like this one, yeah? The cross-sectional area where the heat flow through. The heat flow through. So this cross-sectional area, it can be, this area can be circle, sometimes can be circle, sometimes can be, you know, the shape, yeah, can varies. It can be a circle shape, it can be a rectangular shape, with width and height. But if the circle, it will give you the diameter. So pi r square to find the area, or if it's square is width times height. So it depends on the questions, yeah. The heat flow, the cross-sectional area where the heat flow through. And this cross-sectional area is meter square. And then we have dt over dx. dt over dx is we call the temperature gradient. Temperature gradient. Why we have temperature gradient? Temperature gradient, the unit is Kelvin per meter, because temperature is in Kelvin, and dx, x is the distance, is meter, so Kelvin per meter. Okay, this change of temperature can also be in degrees Celsius. I can have two units, either Kelvin or degrees Celsius. So so it can also be degrees Celsius per meter. So temperature gradient has two units, Kelvin per meter or degrees Celsius per meter. Same like this thermal conductivity, we can have per Kelvin or or per degree Celsius. Okay, why you can have two different units? Kelvin can be accepted and degree Celsius also can be accepted. This one I will explain later. Yeah, this one can be either Kelvin or degree Celsius. This one also Kelvin or degree Celsius. Why there are two units, I will explain later. Okay, now, first of all, why we have temperature gradient? As I said before, why heat conduction happen? Why heat conduction happen? Heat conduction happen because we have two different temperature. Heat only flow when there are difference in temperature. If the temperature is the same, it don't flow. So there must exist two different temperature, only heat can flow. And heat always flow from hot temperature to cold temperature. Okay? Back to the equation. That's why we have temperature gradient. Temperature gradient means there exists two different temperature. It exists two different temperature separated by a certain distance. Like the length of the rod. Yeah? Like you see this one, the hot one. So we have a temperature, initial temperature here. Yeah, we have the initial temperature here, which is a hot one, and we have the final temperature here. We have the final temperature here, which is the cold, and separated by a distance. These two different temperature is separated by a certain distance called x. So that's why we have temperature gradient. We have temperature gradient, which is what we call delta T over delta X. Delta T over delta X. So this is the change in temperature. The change in temperature, we use the final temperature minus the initial temperature. Initial temperature divided by the X, distance between the two. The distance between the two temperature. We also can write this as dt over dx. This is what we call temperature gradient. Why we have temperature gradient? Because heat only flow when you have temperature gradient. If temperature gradient equal to 0, there's no heat flow. For example, like okay, I think I explained quite well already for this one. For example, like you look back to the equation. If the temperature gradient is 0. What do you think is the rate of heat flow? What do you think is the rate of heat flow? dQ over dt. Yeah? Negative Ka times 0. Of course, you will get 0. There's no heat flow when the temperature gradient is 0. Temperature gradient 0 means same temperature. Same temperature. No difference in temperature. Okay? Alright. That's the temperature gradient. So, that's the thing. Okay? So, like this one. You see the rod here? We have a hot high temperature and we have cold temperature. When we have two different temperature, then there are heat flow. If these two different ends has same temperature, there's no heat flow. Okay, like this one, 0, 0 rate of heat flow. Okay, so I want you to see the direction. Heat flow from hot to cold temperature. Heat always flow from hot end to cold end. So the heat begins from the hot end. So the hot end is the initial temperature. The hot end is the initial temperature, which is the high temperature. And heat flow to the cold end. So the cold end is the final temperature, yeah, which is the low temperature. Example like this hot end is 100 degrees Celsius and this cold end is 20 degrees Celsius. So heat always flow from 100 degrees Celsius to 20 degrees Celsius. Okay, heat always flow from hot to cold end. So the hot end is the initial, the cold end is the final temperature. Okay, you can imagine this this heat flow just like the water flow in the water hose. You can imagine this steel rod like the water hose. Okay, and water is like the heat. Water is like the heat, and water only flow if there is difference in pressure. You must have two different pressure, then only the water will flow. If both ends has same pressure, the heat won't flow. The water won't flow, isn't it? You can imagine the heat like the water, the temperature like the pressure. Yeah, the temperature like the pressure. The heat will flow from high temperature to low temperature. The water also flow from high pressure to low pressure end. If two points have same pressure, the water won't flow. If both points have the same temperature, the heat won't flow. Just like that. Yeah, very simple. Yeah. So back to the equation, I want you to take note about the negative sign. Yeah, why this equation has a negative sign? Why? Why it has a negative sign? The negative means the heat only flow in the direction of decreasing temperature. Heat only flow in the direction of decreasing temperature. What does it mean? Heat flow in the direction of decreasing temperature. That means heat flow from high temperature to decrease until low temperature. That's what it means. Heat only flow from high temperature to low temperature or hot temperature to cold temperature. Heat flow in the direction of decreasing temperature. Decreasing temperature, like this graph, you see? Heat only flow in the direction of decreasing temperature. From high temperature flow to a cold temperature. Decreasing temperature. So heat flow in the from hot to cold. So this is what the negative means. So if we look carefully, why we must have this negative sign? Why we must have this negative sign? Okay. You see, this change of temperature is final temperature minus initial temperature, isn't it? Final temperature minus initial temperature. The final temperature is the cold temperature. Because heat only flow from hot temperature to cold temperature. The initial temperature is the hot temperature. The final temperature is the cold temperature. And the initial temperature is the hot temperature. The final temperature is the cold temperature. So when we take final minus the heat, we take final temperature minus the initial temperature. That means we take a small temperature minus a high temperature. A small temperature minus a high. A low minus high. Of course, you get negative value. A a small value, a cold temperature, a small temperature, minus a high temperature, hot temperature, small minus big, you get a negative value. But our rate of heat flow, dq over dt, our q over delta T, our dq over dt must be positive, can never be negative, must be positive. And here, but here, cold minus hot, low minus high, you get a negative. So, but this dq over dt must be positive. So, in order to make this thing become positive, we put a negative sign here. We put a negative sign here so that when negative multiply negative, get a positive value for the rate of heat flow. Understand? That's why we have a negative sign here, so that when negative multiply negative, you get a positive for the rate of heat flow. The rate of heat flow need to be in positive value. So this negative means what? This negative means the initial temperature is a hot temperature and the final temperature is a cold temperature. And it also means, this negative means the heat flow from hot to cold temperature. That means the heat flow in the direction of decreasing temperature. Did you get that? Okay, I explained to the core. Okay, now about the unit just now. Why the thermal conductivity can be in Kelvin, also can be in degrees Celsius. The temperature gradient can also be in Kelvin or degrees Celsius. Why? Why there are two units? Okay, here I explain. Because, okay, I want to clarify one thing. This you see, the change, this is about the change in temperature, dt. Change of temperature is final minus initial temperature. So it involves two temperature. It involves two temperature. Okay, because it involves two temperature, that's why we can accept two unit, either degrees Celsius or Kelvin. We can use degrees Celsius minus degrees Celsius, or we can also use Kelvin minus Kelvin. But why? Okay, I will explain why. Because of this. You see. Now, we are talking about heat conduction. We haven't go to thermal expansion, but later on we will touch about thermal expansion. Now, heat conduction, which is dq over dt equal to negative Ka delta T over delta X. This delta T can both degrees Celsius or Kelvin. Delta T, delta is called the change. When we talk about change of temperature or delta T, it is the final temperature minus the initial temperature. We can accept both unit, degrees Celsius or Kelvin. Why? Look at this. For example, let's say the final temperature is 1 degree Celsius and the initial temperature is 0 degrees Celsius. Let's say, if we change to Kelvin, that means we plus each of the temperature we plus 273, isn't it? This 1 degree Celsius plus 273, we will get 274. And also the 0 degree Celsius plus 273, 0 plus 273, we also get 273. Okay? 1 plus 273, we get 274. 0 plus 273, we get 273. So, when we change the degree Celsius become Kelvin, for both temperature, and we minus out 1 minus 0, you get 1 degree Celsius. 274 minus 273, you get 1 Kelvin. The value is still the same, 1 and 1. You see or not? That means, here you see, the temperature increase by one value. You see, if the degree Celsius, if the temperature increase by 1, the Kelvin also increase by 1. The value is the same. So we can say delta T, if the change of temperature is 1 degree Celsius, is the same as 1 Kelvin. 1 Kelvin change. That's why we can accept both unit, either degree Celsius or Kelvin. We can accept both. Degree Celsius can, or Kelvin also can. So when we talk about change of temperature, like this one, heat conduction, we can use degree Celsius or Kelvin. So if the question gives you the temperature in degree Celsius, you can still use degree Celsius. No need to change to Kelvin. But if you change to Kelvin, you will still get the same answer. Yeah, you still get the same answer for change of temperature. So it can accept both units. Understand? So change of temperature can accept both units. So the others I will explain more. Okay. So on a second. Yeah. All the others, the further explanation I will explain more. Okay. Now that's why our thermal conductivity, since the change of temperature can accept both degree Celsius or Kelvin. That's why our thermal conductivity can be in Kelvin or degree Celsius. Our temperature gradient also can be Kelvin or degree Celsius. Okay. Yeah, that's it for the first part. Okay, stay tuned for the second part.